Good morning everyone. I am Sobhan Kumar Paja from Mechanical Engineering Department of Ideal Institute of Engineering.
Last class we discussed some basic terminologies. So today we will continue the same topic with some example. Before that we discussed some basic things which are useful, that is unilateral limits. It occurs when both maximum limit and minimum limit are either above or below the basic size. So here we have considered two example. The first one is both the maximum limit and minimum limit are above the basic size, and the second one is both the maximum limit and minimum limit are below the basic size. So the first one is both the upper and lower limit are above the basic size. So here we consider as the dimension 525 plus 0.18 plus 0.10. Here the basic size is 25 mm, and the upper limit is 25 plus 0.18, that is 25.18 mm, and the lower limit is 25 plus 0.10 mm, that is 25.10 mm, and the tolerance is the difference between the upper limit and lower limit. So this 25.18 minus 25.10, that is 0.08 mm. So if we represent it on the diagram, so this one is the basic, this one is 0 line, and this one is the datum line. So this one is the basic size, and the lower limit, that is 25.10 mm, this distance, and the upper limit, that is 25.18 mm, is this distance. So the second example is both the dimensions are below the basic size. So here we consider the example 525 minus 0.10 and minus 0.20. So here the basic size is 25 mm and the upper limit is 25 minus 0.10, that is 24.90 mm, and the lower limit is 25 minus 0.20 mm, that is 24.80 mm, and the tolerance is the difference between the upper limit and lower limit, that is 0.10 mm. So this one is the basic size, as both the dimensions given are negative sign, so we have to represent the diagram below the basic size. So this one is the upper limit, and this distance is on the lower limit. So for unilateral limits, a case may arise when one of the limits coincides with the basic size. So here also we consider two examples, that is first one is 525 plus 0.20, 0.00. So here the lower limit, that is when the lower deviation is 0.00, it is the same lower limit is same as the basic size, that is 25 mm. This one is the basic size, and this one is the lower limit, which is same as the basic size, and the upper limit is 25 plus 0.20. This one is the upper limit. And for the second case, here the upper deviation is same as the basic size, so the upper limit is 25 plus 0.00. so this is same as the basic size, this one is basic size 25 mm, and upper limit same 25 mm, and the lower limit is 25 minus 0.10. So this is slightly lower than the upper limit, that is equal to the basic size for this case. And now we will discuss the bilateral limits. It occurs when the maximum limit is above and the minimum limit is below the basic size. So here we consider example 525 plus minus 0.04, or we can represent it as 525, the superscript plus 0.04 and subscript is minus 0.04. So here the basic size is 25 mm and the upper limit is 25 plus 0.04, that is 25.04 mm, and the lower limit is 25 minus 0.04, that is 24.96 mm, and the tolerance is 25.04 minus 24.96, that is the difference between the upper limit and the lower limit, that is equals to 0.08 mm. So this one is the basic size that is 25 mm, and this one is the upper limit that is 25.04, that is above the basic size, and the lower limit that is 24.96 mm, this is below the basic size, that is equals to 25 mm. So this distance is 24.96 mm and this distance is 25.04 mm. Now let's take one example, that is a shaft has a dimension of 535 minus 0.009 and the subscript minus 0.025 mm. So we have to find out the values of fundamental deviation and the tolerance. Here 4 options are given, so from one is correct, so we have to find the correct answer. So before that, to find the fundamental deviation, we can directly say the answer, that is minus 0.009. That is because the definition of fundamental deviation is, it is either the upper deviation or the lower deviation which is nearer to the zero line. So here nearer to the zero line is minus 0.009, so it should be the fundamental deviation. So if we represent the dimension on the diagram, so we can write here the basic size is 35 mm, so this one is the basic size, and minus 0.009, this one is the lower deviation, that is, and minus 0.009, it is the upper deviation, and minus 0.025, this is the lower deviation. So, and we all know that the deviations are measured from the zero line, so this distance, this is upper deviation, this is minus 0.009 mm, and this one is the lower deviation, that is minus 0.025 mm. So the basic size is 35 mm and the upper limit is the basic size minus the lower deviation, that is minus 0.009. So the upper limit is 34.991 and the lower limit is 35.0 minus the lower deviation, that is minus 0.025. So it is 34.975 mm. So this should be mm and this should be mm. So the fundamental deviation is, we have already said the fundamental deviation is minus 0.009 mm, but to find the numerical value we have to use this formula, that is basic size minus the nearer limit, that is basic size is 35 mm and nearer limit, that is the, for this case this is the upper limit, that is 34.991. so the fundamental deviation is 0.009 mm, and to find the tolerance we have already got the value of the upper limit and lower limit, that is 34.991, that is the upper limit, and the lower limit is 34.975. if we subtract the lower limit from the upper limit, we get the value of tolerance 0.016 mm. So the correct option is answer D. So today up to that we will discuss the different types of fits on the next class. Thank you.